Now remember I told you that the Smith chart is used to relate the reflection coefficient and the load impedance. So let's spend a little time talking about the load impedance. The load impedance can be made up of two parts, the real part and the imaginary part of the load impedance, and that's given in ohms. The Smith chart does not plot the load impedance because there's no limit to it. It could be huge, it could be small. Instead, we plot the normalized load impedance. We take the load and we divide it by the characteristic impedance, and that gives us a normalized load impedance written with small letters in your book, and that has two parts. And I'm going to color code these because we're going to draw them on the Smith chart in these colors. It has a real part, RL, and it has an imaginary part, XL, and it has no units. It's unitless because it's normalized. It's ohms divided by ohms here, so it ends up with no units. And that's what we're going to be plotting on the Smith chart. When we plot the real part, we use these circles that you see most prominently on the Smith chart. This circle right here is when our real part is equal to 1. That's one of the real circles, and you can tell that the real part is 1 by reading the value off right there. So this is the RL, normalized real part of 1. Let's find the normalized real part of a half. Right here, the value is a half, and so this circle has the real part of a half. Those are supposed to really be circles. I'm just not a very good circle drawer. So here's RL equals 0.5. Now let's look at RL equals 0. Out here, that's the RL equals 0 circle. Now there's another hint on the Smith chart that tells us what we're reading. Right there, it says it's the resistive component, R divided by Z naught. So that was this divided by Z naught. That's what we're plotting in the green circles. Now there's another set of circles here if you look closely, and that's these blue circles that are sort of half circles. Take a look at this one right here. See, that's a part of a circle. It actually just keeps going, you know, up and down and around, but the only part that we're using is the portion that's shown here. These are the imaginary parts, and we read them around the outside line. We also read that, we can tell that that's what we're reading by noticing this right here. These are the XL terms. That's what we're plotting here. This is when XL is equal to 1. And here, there's the half point. That's when XL is 0.5. So kind of see how that's a circle too? See it going up and down? It's a very big circle with a center out here someplace. Now, right here, this line is the XL equals 0 line, and then down below we start getting negative values right here. So the XL equals minus 1 line is this one, and the XL equals minus a half line is right here. So those are the two sets of circles that we're going to be plotting on this Smith chart. So the negatives, XL is negative is down here, and XL positive is up here. In the center, that's where XL is equal to 0. Now let's do a little example. Let's just examine the case where our load, ZL, is equal to 50 plus J50 ohms, and our characteristic impedance is 50 ohms. In order to plot this on a Smith chart, I have to normalize it. ZL divided by Z0 is going to be 1 plus J1. So let's find our real circle of 1. That's right here. And let's find our positive 1. That's right there. So this point right there is ZL equals 1 plus J1. Let's find our reflection coefficient at that point. Run a straight line from the center through my point, just like this. Read the phase off this term right there. 10, 20, 30, 40, 50, 60. Looks like 65 degrees. Read its magnitude by drawing little lines on your paper. Right there, and carrying it down to the magnitude line. Right there. Your magnitude is 0.4. That's your reflection coefficient. 0.4, angle is 65 degrees.